Welcome to Ask Me Anything ARCore. I am your host, Taylor Mitchell. I am an engineer on ARCore Cloud Anchors and other place-based AR experiences. Next, I have here with me Fred.
Hi, I'm Fred Sauer. I'm a developer advocate, and I work entirely on ARCore.
Hey, I'm Max Dzitsiuk, and I'm an engineer working on depth API.
Hi, I'm Brian Kim. I'm an engineer working on recording playback and other camera APIs.
We want this session to be as helpful to you as possible, so please don't forget to post your questions. Just tap on the Q&A icon to the right side of the live stream and on the IO website to post or vote on questions. We'll choose the top voted questions to answer during the session and make sure you upvote your favorites. Now let's get started. First question, what are some ARCore best practices? Fred, would you like to start for us?
Sure. That's actually a really good question. So I think the thing that I see developers struggle with the most is that they get this idea for an AR application and they dive right in and they build like a gorgeous application and they forget to test the application with end users and see what it's like to get started with an app for someone who doesn't know AR. So as AR developers, we know the tech really well. We know that we need to move our devices around to get really good tracking. But AR is relatively new for consumers, even for business users. And so it's really important that you test your application with users who haven't used AR before, haven't used your application before, and just stand back and watch and see what it's like. Do they figure out what they need to do? Can they get to that first moment of delight? That's when they see an AR character in the world or a piece of equipment in a warehouse or whatever your use case is. So really test your apps with users. And don't help them out in the beginning. Just stand back and see what they do, and then use that to inform the user experience of your app. What kind of hints do you give on screen? How do you help the user come to that first moment of delight?
Yeah, I guess I could add a little bit to that. I agree with Fred that guiding the user with good UI is probably the most important good practice. One example of this is the recent new filters in the TikTok app. So they've added a filter where you can place graffiti and project it in your physical space. And the way the filter works is it collects some environment understanding of the area beforehand. And the way it's presented to user is by having a circular progress bar that fills up the more you scan your area. So it's kind of like an intuitive way to inform the user when they can interact with the physical world.
And one other area where this needing movement might be kind of unexpected is that one thing to keep in mind for recording and playback is that the datasets by default only contain raw sensor data like camera images, IMU data. So even if you have planes detected at the beginning of recording in your session, during playback, ARCore will still try to redetect planes on the sensor data. So you have to remember users to move around at the beginning of recording, even when there are already planes.
Yeah, similar to what Max and Brian both said, when hosting a Cloud Anchor, the most important thing is to get a lot of views around the same point. And when users are first trying to do this, they generally just stand in one spot and move their camera around to the environment, which doesn't help nearly as much as physically moving around the spot. All right, let's go to the next question. What's the difference between depth and raw depth? Max, can you help us out with that?
Yeah, I can take this one. So both depths and raw depths are estimation of the distance between the camera and the physical world that the camera sees. The primary difference between them is in accuracy and coverage. So generally, raw depth API has a higher accuracy of the estimate for depth, but some areas of the image might have missing information. So the value of 0 in the raw depth image means there is no estimate for that area. On the other hand, full depth has an estimate in each pixel, but it generally can be lower accuracy than the raw depth. That's the technical answer for the difference, but I think this question more asks on what should I use in my app? Should I use raw depths or full depths? And this generally depends mostly on the experience you're building. If you're building an app that uses depths for some image effects, like let's say occlusion or relighting, you should be using just full depths API. And if you're using it for some geometry understanding tasks, like measurements or 3D reconstruction, you should be generally using raw depths API because you could benefit from the higher accuracy.
Yeah, so I think a way to look at it is maybe visual effects versus geometry or geometric understanding. So if you're trying to measure anything in AR, then you want raw depth. Almost everything else, you want full depth, which gives you complete coverage over the screen, gives you nice interpolated results.
Right.
Awesome. Thank you both. All right. Next question. A lot of us are struggling to integrate Android widgets or UI components without scene form. Is there a planned replacement for it or a recommended best practices to integrate such objects into AR world space? Fred, do you have a good idea of that?
Yeah, I can talk about that a little bit. So there's not a direct replacement for scene form, but you're free to use any 3D library that you have for rendering. The same libraries that you would use in a 3D game that's not AR based would totally work in AR. What AR does is the device does some tracking to tell you where your device's phone is relative to the environment. And there's a pass-through image from the camera usually that is put behind the 3D scene that you create. So if you're making a game, if you're making a 3D game, you place 3D objects in a virtual world. If you make an AR game, you're placing 3D objects in the real world. In both cases, the rendering of the 3D objects is the same. It's often a little bit easier in AR because there's less to render. You have just an object and the rest is the pass-through camera image. If you're really looking for something and you think OpenGL is a little bit too low level for you and you haven't yet fallen in love with any of the existing 3D libraries, I suggest maybe opening up the Hello AR Java sample in our ARCore SDK for Android. There that you'll find a very thin abstraction layer on OpenGL that makes it a little bit easier to write OpenGL-based applications in Java. We have a version coming in Kotlin, if it's not already there, that's going to do the same thing. It's not intended as a full-blown library, but it's what we use in our own samples to build 3D applications quickly and not have to worry so much about the boilerplate code that comes with OpenGL. Yeah, so feel free to adopt that and take it into your application and build on it. If you're building something really advanced, it's probably not the right framework for you, but in that case, you probably have a 3D library. If you just want something lightweight, you're building sort of prototypes, demo apps, and you want to have something to go off of, I would suggest taking a look at that and see if that would work for you.
Yeah, I definitely agree with you there, Fred. Moving off of SceneForm was a struggle for some of our internal apps as well, but using some of those sample libraries really helped us get started. All right, let's move on. ARCore Depth API works in a range up to 8 meters. Would it be possible to increase this range? It would be especially beneficial for outdoor AR. Max?
Yeah, I can take this one. So thanks for the question. We definitely heard this feedback. The limitation of depth 8 meters comes generally from the format we're using, depth 16. So that's basically the only suitable format for the images right now in Android that balances the performance needs of real-time estimation for depths and the accuracy. So it has 13 bits for the depths in millimeters and 3 bits for the confidence. The confidence we're exposing as a separate image, so we're not using those 3 bits, but we are limited right now to those 13 bits for the depths, and the mass comes up to 8.1 meters if we're estimating at a millimeter accuracy. There is some early exploration of different ways to solve this One is using floating point precision to expose depths. Unfortunately, there is right now no Android format that could support this. So we're looking forward to overcoming this limitation with newer formats.
Thank you. Next question. I've noticed that while horizontal plane detection is pretty strong, vertical plane detection is far less reliable. Is this just because my walls are boring, or is this a known limitation of ARCore? Who can help out with this one?
I can help. First, your walls are not boring. They might not have as many visual features. Even floors that are single color get scuff marks on them, and there's a lot of visual features for algorithms to pick up. So I would say in general, walls can be a little bit more of a challenge. There is a new, in ARCore 124, which came out yesterday, there's a new depth-based hit test that you can use that will do a better job of interpolating sort of the blank space. So if you have a wall with maybe a few photos or a few features and blank areas in between, you'll now be able to do a hit test that is more likely to give you a reasonable result than previously. So I can definitely recommend that.
Awesome, thank you. New ARCore Recording API is a great improvement. Does it also record the data from IMU and TOF sensors? Brian?
Yeah, so datasets generally contain pretty much any raw sensor data that passes through ARCore. So that includes IMU data, time-of-flight camera data if it's available, and also any high-res images that get requested by the client app.
Okay.
Yeah, and maybe to add, importantly, there's no GPS data or location data that's recorded. It's simply the sensors that we use for the ARCore session for tracking. So if the device has an active depth sensor, like a time of flight sensor, that data is in there. The camera is in there so that we can play back the camera feed. The IMU is there, which is sort of, I guess, Brian, that's the acceleration and the gyro data. It's basically how your device is oriented and how fast it's accelerating. And those are all used for AR tracking.
Thank you both. Next question. Why should I attach my objects to an ARCore trackable as opposed to placing it at a coordinate in space?
I'm happy to take this one as well, because I said maybe the UX feedback was the most important thing. I think this is a very close second, if not maybe competing for first place. So when developers start going with AR, they see that their device provides a location XYZ coordinates moving through space, and they're like, fantastic. And they can do a hit test. So they send a virtual array out of the phone where maybe the user is tapped onto the floor. And then you get a location back, a pose, that's position orientation. And it's just so attractive to then place your AR character or other object at that location and think you're done. This seems like a perfectly reasonable approach, but it actually is slightly at odds with the way that ARCore does tracking and the way that it occasionally recomputes sort of the mathematical shape of the space that it's tracking. And so to account for this, we came up with anchors. And anchors are a way for your app to communicate to ARCore that that particular location where that anchor is attached is important to you, and that you want your virtual character or virtual object to appear solid and attached to the world at that point. So for example, if you allow a plane to be detected on the floor and you send a hit test, raycast into the scene and you find a spot, you have two options for placing an object. One is to just place the object at absolute coordinates. The other is to attach an anchor and attach your object to that anchor. You should definitely create the anchor, attach the object to the anchor. That will make that object appear much more solid and rigid attached to the world, because ARCore, when it does these shifts to kind of space, it will counteract those shifts in the anchor positions. And so the absolute X, Y, Z coordinates of your object will change over time, but the perceived location of the object will stay fixed. So if you ever find yourself placing an object with XYZ coordinates, you're probably doing it wrong. There's a few cases where you might do it, but always use an anchor, and then maybe ask for an exception every once in a while. Hope that is clear advice. Always use an anchor.
Thank you, Fred. That seems very clear to me. On to the next question. Is it possible to play back an AR session on a device that's not ARCore supported?
So there are kind of two ways to play back datasets. So the first, so as I mentioned before, datasets by default only record raw data, which means that for normal playback, if you want poses, planes, etc., you need to have ARCore installed to rerun those algorithms. But you can record arbitrary sensor data, arbitrary data tracks into data sets, which means that you can include the camera pose and any other data you want, like planes, and then play it back in any media player that supports those data tracks and compute any projection matrices or other calculations you need on the client side.
Go ahead.
Sorry, in that case, you would not need ARCore installed.
To add on a little bit of that, Fred had mentioned earlier that we do not store GPS coordinates. One thing we do in our team using this API that he just described is that we do store that GPS into that off track so that we can use it in some of our place-based experiences.
Yeah, so that's a great example of a custom track that developer would use. Brian mentioned keeping track of the pose of the device. So basically all of the derivative results from ARCore storing that. I like your example of GPS because you can sort of enhance the recording and put whatever data you want in there. There's also a sample app that was released yesterday called VoxPlop that we talked about in some of our sessions. And what it does is it takes AR recording and it puts additional data in there, like the location of a virtual character, the pitch of the audio, and even the audio stream. And this allows that AR experience to be played back on another device, and then for a second user to manipulate some of the settings, go back and edit the video again. And so you can have a shareable experience that can be edited and re-edited again and again.
Okay, next question. ARCore supports several types of hit tests: plane, feature point, depth, instant placement. Which one should I use in my app? I'll start with this one since I have a different answer than everyone else. So when we're using cloud anchors, for example, we want to attach things into the real world somehow. And I find the best place and most simple way to do that is to use planes because we know that something is there. But for a lot of other experiences that don't need persistent anchors, maybe this is not the best way. Someone else want to chime in?
I have strong opinions. I think the one you probably want to use the most is the depth-based hit test, but there's definitely use cases for each of the types. That's frankly why we have all the different types. One that's particularly interesting but requires a little bit of trade-off is an instant placement hit test. So in the very beginning, we had this question about getting users to move their devices, and sometimes it's really hard. We have in many of our applications a hand that shows holding a phone that moves around in a circular motion on the screen. And the intent there is to tell users that they should move their phone through space, just like the hand is. But when we tested this out with users, we found that some users looked at that and thought it was a loading animation. So they would hold their phone very still, waiting for something to happen. And this is the challenge with any kind of application that reaches a large number of users is, different UX will mean different things to different people. And so what we'd really like to do in that case is allow the user to get to that first moment of delight, to place an AR object even before they start moving. And that way we can encourage them to walk around the virtual character, and that movement actually will give us the tracking. So instant placement does just that. It allows you to find a location on the screen, for example, letting the user tap. And then rather than use full depth information and AR tracking, we just take the actual pixels on the screen and track based on that. And that's useful because we can do that from the very first frame that the app starts rendering. And that means we can place an AR character at this location where the user is tapped, and then the user can start interacting with it. And as soon as the user starts moving their phone through the space, maybe because they're walking closer to the character, then ARCore can take that motion, parallax motion, and use that to develop tracking. The trade-off that I mentioned, though, is that when you use instant placement, we don't know the depth yet. We have to guess how far away the floor is or how far away the table is. So you as a developer have to provide that estimate to us. And then ARCore will use that estimate for the position and refine that estimate once the user starts moving. It's then up to you to make an adjustment to how the object is displayed on the screen to make sure it doesn't pop suddenly when the actual depth is known. So you can read about that in our developer documentation. So instant placement is super powerful. It lets you place objects instantly at the start of the session before this motion, but there's a little bit more work to do on the UX side. All the other hit test types have their own use cases, but they all require sort of tracking to be in place and for the user to be moving around. And again, my favorite one is the depth one. So start with that if you don't know what to do.
Yeah, I can add a little bit about the depth hit test. Since it's so new, we just released it on this I/O. So that's the only hit test that's available everywhere in the image, even on like a blank wall or on a curvy object, like a side of a couch, for example. So plane hit tests are only available in planar regions. And often you have to make a choice between those two. They both can be available in the same point. And if you're building like a furniture app, you might still select the plane because you only can place the furniture on the floor. But generally, depth hit test provides a higher accuracy of the position and the orientation of the hit test. One caveat there is that it's available not on all ARCore devices, but on depth-supported ARCore devices that are listed on our developer portal. But this list is growing pretty fast.
Thank you all. What is the difference between Unity AR Foundation, ARCore XR plugin, ARKit XR plugin, and ARCore extensions for AR Foundation? Do I need them all to make an AR app for Unity? Fred, can you help us out with this?
Yes, absolutely. So that's quite a mouthful in the long list of plugins. I think the way to remember this is AR Foundation is the common set of APIs that are supported in the latest versions of Unity that allow you to build AR applications that are cross-platform. For certain ARCore features that don't have APIs represented or encoded in AR Foundation, think, for example, cloud anchors, that's where you would use ARCore extensions. So this is extensions that we've added to AR Foundation for ARCore specific features. So you have a choice as a developer when you're starting a new Unity application. You can either stick to just the base layer functionality in AR Foundation, and these will give you a common set of APIs that work very similarly across Android and iOS. But if you want to use additional features like cloud anchors from ARCore, then you should also install the ARCore extensions. So our recommendation is just put that in there, and then any features you need will already be available. The other plugins mentioned in this question, like the ARCore XR plugin, the ARKit XR plugin, those are plugins that provide the AR Foundation functionality for each of the respective platforms, but they're marked as dependencies, so you'll sort of get those for free automatically or be forced to use them. So you don't have to think about them, but they are the implementing packages. So yeah, AR Foundation, and then optionally ARCore extensions.
Thank you, Fred. All right. Will Depth API and raw depth be extended to other mid-range smartphones?
Mhm. Right. So currently the set of devices where depth API and raw depth API is the same. And there is generally very little overhead if you use both raw depth API and depth API at the same time, because internally they are using a lot of same resources. But like computing depth image from motion is a pretty resource costly task. So naturally, not all devices can handle it. Also, we need to make sure there is room for the actual app experience to run. So we're not occupying the whole CPU capacity of the device. So we're playing it on a safe side there and not allowing some devices to enable depth API. But the list is growing. Right now, I think it's at 350 million depth-enabled devices. So yes, it is expanding, and soon enough it's going to be even larger. That has been a focus of our work as well.
Yeah, we'd really like to make it available on all devices, but it's ultimately that trade-off between CPU, available CPU performance, how much is available to the app. And so as we can optimize algorithms, we can enable more devices. As new devices come out that are more performant, the list grows as well. We'll leave it up to Max if whether we can get to all devices eventually, all ARCore supported devices or not. That's certainly our goal.
Yep.
All right, thank you both. Here's a good question. What about using the multiple cameras on mini phones instead of relying on the user to move the phone? I'm guessing this is asking about why don't we use multiple cameras to do the parallax instead?
Yeah, that's a really good question. So we have experimented with this a little bit, and I believe we have at least one device that is doing this. The main challenge is that to get really good depth perception, you need to view the scene from different perspectives that are at least a few centimeters apart. So think about our eyes. I think they're roughly 3.5 centimeters apart for the average person, some a little bit wider, some a little bit narrower, but that gives you quite good depth perception. On many of these phones that have multiple cameras, the dual cameras are very close to each other. So say a centimeter apart or maybe a centimeter and a half apart. And that's often not enough to get really good depth perception. So we still want to use that device motion. But it is something that can help us at the start of the scene. A little bit of depth is always better. A little bit of parallax always better than none. But whether we enable that globally across devices, I think it would get really interesting if devices had two cameras that were really wide apart. So think on the right edge of the device and the left edge, then you'd have pretty decent separation, pretty similar to human eyes, and that might be nice.
Right. Yes. As Fred said, there is a limitation on the distance we can estimate with a limited baseline that we usually have on the phones. So depth API currently merges some like multiple sources of information behind the scenes. Like if the device has active depth sensor, it's also taken into account. There's one device where we, I think, use dual camera source as well, but only during the initialization, because after there is motion, there is actually no need for this dual camera baseline. I think there is also some limitations on how the cameras have to be implemented in the Android stack, and that adoption is also growing, and we're looking into how many devices can technically support dual camera depths.
Yeah, I think it's important there to realize as well that the camera stack consumes quite a bit of power, and so lighting up a second camera sensor can consume a lot of the power budget. So that the trade-off that Max mentioned of like have two cameras at the beginning of the session, but as soon as there's motion, go back to one camera. It's a nice trade-off. But there is that complexity of how is the camera defined? Can we integrate with it? How's it calibrated? All these things.
Thank you all. I think that ends our time for the session and wraps up our live Q&A. Thank you all for joining us today for this Ask Me Anything. We hope you enjoyed your experience and learned more about ARCore. You can find some of our follow-up resources at developers.google.com/AR. Thanks again for joining us for Ask Me Anything Google I/O 2021. We'll see you soon.
Great questions. Thanks, everyone.